We will now discuss the questions that have appeared in the TS Set 2019 examination from the section Linear Algebra. These questions are suitable for the aspirants of JL, DL, AP Set and CSIR Net also. And I acknowledge the inputs that are given by my student Sripad Venkatesh from CVR College of Engineering. Now this question is based on the concept of the dimension of a subspace, and this bears a question number 61 with this question ID. The given question is the dimension of the vector subspace W given by 2 by 2 matrices A, B, C, D, where A plus B is equal to C, B plus C is equal to D, C plus A is equal to B of M2 over C. We are given 4 options. Right. So let's now discuss the solution of the problem in detail. We first have a vector space. What is the given vector space to us? M2C. What is this? It is a vector space of all 2 by 2 matrices with the entries from the complex field and over the complex field. Right. And we have a W, which is a subspace of V given by W is equal to the set of all 2 by 2 matrices A, B, C, D, where A, B, C, D are complex numbers and they satisfy the equations A plus B is equal to C, B plus C is equal to D, C plus A is equal to B. First, let us take A plus B is equal to C and C plus A is equal to B, the first equation and the third equation. Now, for C, we substitute in this equation, for C, we substitute A plus B and simplify. So, C is A plus B plus A is equal to B. So, B cancels, 2A is equal to 0 will imply A is equal to 0. When you substitute A is equal to 0 in the first equation, you will get C is equal to B. C is equal to B. And so far, we have not utilized the second equation. Take the second equation. So you will get C is equal to B, where B is arbitrary. Then D will be equal to B plus C, that is C is B, and B plus B, that is 2B. So D is equal to 2B. So this will imply then B is equal to C, that is C is equal to B, and D is equal to 2B, where B is arbitrary. And the W will become the set of all those matrices. First row 0, B. For C, C is equal to B, and D is 2B, where B belongs to C. That means the W, in this W, every element of W is a scalar multiple of this 0, 1, 1, 2. Because you can take B common, 0. So it's just, that means W is spanned by this matrix 0, 1, 1, 2. This is a linear span of. And it is generated by this single element, and this single matrix is non-zero, and every singleton set consisting of a non-zero vector is always linearly independent. Therefore, it generates and it is linearly independent. Therefore, it is a basis. How many elements are there in the basis? Only one. Who is he? 0, 1, 1, 2. So, what is the dimension? The dimension of the number of elements in a basis. So, the dimension of W is over C is 1. Let's look at our options. And our answer to this question is option 1. So that is a very easy question, and you might be noticing, because we are talking about 2019 question, 2023 March question paper, 2023 December question paper, October 2023 March 2023 October, two question papers, and this is the third question paper. In all these things, the very first question number 61, is for the dimension of the subspace. It is coming. It's only accidental. But anyway, so let's now move to the next question. Right, this question is based on the concept of the rank. Question 62, and question bears an ID, this one. Now, the given question is, let A belongs to M 4 by 5 R. That means it is a vector space of all 4 by 5 matrices with real entries. And let A belongs to that and be a 4 by 5 matrix of rank 3. So the rank of A is given to be 3 with entries from R. Anyway, and let A transpose denote the transpose matrix of A. Then the question is, the rank of A transpose A is how much? We are given 4 options. Now, we are given A belongs to M 4 by 5 over R, and the rank of A is equal to 3. And it is a well-known theorem and a result in many textbooks. That is, they recall this result. Rank of A is equal to rank of A transpose A for any A belongs to M by N over R. And you have to note down, this result is true only for the vector space of M by N matrices over real entries, with real entries and over the real field only. This is only true for R, over R only true. Over C, it is not going to be true. So be careful. For this only, so it is A belongs to M 4 by 5 over R. Therefore, this is applicable. And the rank of A is given to be 3. Therefore, the rank of A transpose A is 3. Right. And the answer is option 3. Again, it's option 3. The answer 3 is there. And I suggest to every aspirant of these competitive examinations, at least go through what is the proof of this one from the standard textbooks, right? And the proof runs on the concepts of the null space. That is the clue that I give you. So you consult a standard textbook, and if you know the proof of it, then you will be very confident in remembering these results. Right. Let's now move to, and you may note down. Rank of A is equal to rank of A transpose A is equal to rank of AA transpose for any A belongs to M by N over R. This condition is a must. So this theorem says the matrix A, A transpose, AA transpose, A transpose A, all these 4 matrices have the same rank for any A belongs to M by N over R. This is a must condition. You have to remember this result. Agreed. Let's now move to the next question. This is also, again, the question is on rank. Question bears the number, serial number 63, and this is the ID for that. The given question is, let A be A, B 4 by 4 matrices with the entries from real numbers. Then which of the following statements is true? And option 1, rank of A plus B is equal to rank of A plus rank of B. Option 2, rank of AB is equal to rank of A multiplied by rank of B. Option 3, rank of AB less than or equal to minimum of rank of A, comma rank of B. Option 4, rank of A plus B is equal to the minimum of rank of A, comma rank of B. Right. And if you see the given question paper in the examination, there is some fumble in the question, in the given question. It says AB belongs to M 4 by 5 over R, something like that it gives. It talks about. So we have taken out that one, and this is the correct one. This means that doesn't make any sense. Therefore, this is the one what I have taken. ABB 4 by 4 matrix. Both are 4 by 4 matrices with real entries. Right. Now, if you have studied your BSc and MSc properly, you might have a list of properties of the ranks of matrices with you. Check it. Check it. Then you will find only one of them is true. What is that one? That is the option 3. Rank of AB is less than or equal to minimum of rank of A and rank of B. The others are not true. Solution. If AB are 4 by 4 matrices with real entries, then rank of AB is less than or equal to rank of minimum of rank of A, comma rank of B, and it is one of the properties of the rank of matrices. Right. The others are not true. Right. So that means the option 3 is true. The answer to this question is option 3. Now that the properties of ranks are required, so why not I list some of the properties of the ranks of the matrices? Yes, I do. So it will be beneficial to you. So I will list out some of the properties of the rank of matrices. Properties of the rank of a matrix. The first property, everybody knows, the rank of a null matrix of any size is 0. Rank of A transpose is equal to rank of A. Right. If A is a matrix of order n, then the rank of A is precisely n if determinant of A not equal to 0. That means when A is non-singular. Rank of A will be less than n if determinant of A is 0. That is, when A is singular, the rank of A is less than n. If A is non-singular, then the rank of AB is equal to the rank of B for any matrix B which is compatible for multiplication with A. Not only this, rank of BA is also rank of B when A is non-singular. When A is non-singular. Right. If A is an m by n matrix, then the rank of A is less than or equal to the minimum of m comma n. This is asked in one of the examinations, one of the questions. Right. And the rank of, no, not this one is given. So the rank of AB less than or equal to minimum of rank of A, comma rank of B. This is the question given. So this is the question given to us. Right. The rank of A plus B less than or equal to rank of A plus rank of B. In the previous question, and it said rank of A plus B is equal to rank of A plus rank of B. This is only, sometimes this is true, not always. And it is also given rank of A plus B is less than or equal to the minimum of rank of A, rank of B. That is not true. So the true statement is rank of A plus B less than or equal to rank of A plus rank of B. That means he has taken these two and kept this one and manipulated the other options in the last question. If A and B are square matrices of the same order n, then the rank of AB is greater than or equal to rank of A plus rank of B minus n. This is a very important property. Remember this one. And just now we have seen the rank of A is equal to rank of A transpose is equal to rank of A transpose A is equal to rank of AA transpose is equal to, they are all equal. And rank of A is equal to rank of A transpose A is true for any A belongs to M by N over R. And if A belongs to M by N over C, this is not going to be true. So these are some of the very important properties of the rank of a matrix. I am sure you will note down these things and be ready for the examination. Right. So let's move to the next question. This is the question based on the concepts of linear transformation. Question number is 64. Its ID is this one. The given question is, let T be a linear transformation from R cube to R cube given by T of x1, x2, x3 is equal to x3, x2, x1. That means this 3 tuple x1, x2, x3 now it will be get interchanged, that is will be written in reverse order, x3, x2, x1. That is the linear transformation T. Now then, which of the following statements is true where I denotes the identity matrix? We are given 4 options. Option 1, determinant of T is equal to 1. The meaning of this one, the determinant of the matrix corresponding to T is 1. So also here. Option 2, T cube is equal to identity. And option 3, T has 3 distinct eigenvalues. Option 4, the smallest n belongs to the set of natural numbers such that T power n is even. That means the smallest n for which T power n is I is the least natural number. That means what is the least natural number which is even? The least natural number which is even is 2. That means T square is equal to identity. Right. So let's now. So for all these things, what is required is the matrix corresponding to T. That means the matrix representation of T you should know. Right. Solution. So to write down the matrix of a given linear transformation, you need a basis. That means you will write down the matrix corresponding to the given basis. Now let us take the standard basis. B is equal to E1, E2, E3, the set with the standard basis for R cube. Now, T of E1, the image of E1 under T. So, T of 1, 0, 0. So, 1, 0, 0 will go to in the reverse order. You write 1, 0, 0 in the reverse order, 0, 0, 1. You write as a linear combination in terms of E1, E2, E3. 0, E1 plus 0, E2 plus 1, E3. Now, the matrix of T with respect to B, that is bracket T suffix B. This is a, and in the 3 by 3 matrix, you have to write 0, 0, 1 as the first column. First column, 0, 0, 1. That is the procedure. So, T of E2, T of 0, 1, 0. Write in reverse order, 0, 1, 0. That is 0, E1 plus 1, E2 plus 0, E3. So, that is 0, 1, 0 as the second column you have to write. So, second column. The first column remains the same. Agreed. T of E3 is equal to T of 0, 0, 1. 0, 0, 1 in reverse order is 1, 0, 0. That is 1, E1 plus 0, E2 plus 0, E3. So, the third column will be 1, 0, 0. So, here you will get 1, 0, 0. Right. We got the matrix of T with respect to B. Now, let's now go on verifying the options. So, note that the determinant of T, that means the matrix of T. Determinant of M is matrix of T. So, what is the determinant? Now, expand this matrix by its first row. That will be 1 into 0 minus 1. 1 into, in bracket, 0 minus 1. So, determinant is minus 1. But whereas in option 1 it is given determinant of t is equal to 1. Therefore, the option 1 is not true. Now you check the eigenvalues of this matrix is 1, 1, minus 1. How do we say that? I will say the determinant of t is minus 1 means the product of the eigenvalues is minus 1. That means lambda 1, lambda 2, lambda 3 is minus 1. And the trace is the sum of the eigenvalues is lambda 1 plus lambda 2 plus lambda 3 is the trace is 1. So lambda 1 plus lambda 2 lambda 3 is 1. Lambda 1 lambda 2 lambda 3 is minus 1. Then what are lambda 1 lambda 2 lambda 3? They are 1, 1, minus 1. And in option 3 it is given t has 3 distinct eigenvalues. But t has 2 of the eigenvalues are same. They are not distinct. So therefore the option 3 is not true. Right. Now you check now. Take T, the matrix of T, and multiply with itself. Please do it. So take this matrix, multiply with itself. Then you will find it is identity. So T square is equal to identity. But in option 2, it is given T cube is equal to identity. So therefore option 2 is not true. But now you see T square is equal to identity, and this is true for the smallest natural number n, for which where n is even. That is the option 4. So now smallest n belongs to n such that t power n is equal to I is even. So who is the smallest natural number n such that n is even is n is 2. And we have already seen d square is equal to I. Therefore, the option 4 is true. And the answer to this question is option 4. And it is a very, very interesting question. And I am sure that you understood the solution of this problem. Let's now move to the next question. That is the question number 65. And this is on the concepts of eigenvalues. The question is 65th question, and it bears this idea. The given question is, let lambda 1, lambda 2 be distinct eigenvalues of a 2 by 2 matrix with complex entries. Then which of the following statements is true? We are given 4 options. Option 1, a square has distinct eigenvalues. Option 2, trace of a power n is lambda power n plus lambda to the power of n for n belongs to n, set of natural numbers. Option 3 is determinant of a square is equal to lambda 1 lambda 2. Option 4 is there exists a lambda belongs to C such that a power n is equal to lambda I for some n belongs to n, the set of natural numbers. So let's now discuss the solution of this problem. We are given lambda 1, lambda 2 are the distinct eigenvalues. Note down the point, distinct eigenvalues of a complex matrix, complex 2 by 2 matrix A. Agreed. Then what I can see is, I will have a glance at these 4 options. Lambda 1, lambda 2 are the eigenvalues of A. Then a power n will have the eigenvalues lambda 1 to the power of n and lambda 2 to the power of n of a power n for any natural number. That is true. That is true. Then the trace of a power n will be the sum of the eigenvalues of a power n, that is lambda 1 to the power of n plus lambda 2 to the power of n. So that means the option 2, that is trace of a power n is equal to lambda 1 to the power of n plus lambda 2 to the power of n is true. For all n belongs to n is true. So the option 2 is true. So we take the option 2, transpose of transpose of a power n is equal to lambda 1 to the power of n plus lambda 2 to the power of n for all n belongs to n. Not transpose of, trace of a power n. Sorry. Right. Now lambda 1, lambda 2 are the distinct eigenvalues of a. Then for any natural number n, a power n will have the eigenvalues lambda 1 to the power of n and lambda to the power of n. It is very well known result. Then you take the trace of a power n, that will be sum of the eigenvalues of a power n. The sum is lambda 1 to the power of n plus lambda to the power of n for all n belongs to n. Agreed. So therefore, the option 2 is true. The answer to this question is option 2. The question is over. Right? In the exam, they stop here, and that is the one, right? Whenever you get the correct answer, there is no need of checking the others. It is not a multiple select question. It is a multiple choice question, wherein only one answer is there. Unique answer will be there. So therefore, you can stop here. But some of our students who are appearing for CSIR NET, suppose this question is asked under part C, that is a multiple select question where you can have more than one answer. Then you have to rule out the other three possibilities in order to say this is the only answer. Right. So for them, I will discuss that direction also now. Let us take the fourth option. There exists a lambda belongs to C such that a power n is equal to lambda I for some natural number n. So for this, I will give a counter example. Let capital A be 1 0 0 0. Yeah, it's a complex matrix. This is also every real number is a complex number. This one is also a matrix over complex field. Right. Now, assume that the option 4 is true. That means you are assuming that there exists a lambda belongs to C such that a power n is equal to lambda I for some n belongs to n. Then a power n is equal to lambda I, because you are assuming that one, this one. But what is a power n? Any number of times you multiply 1 0 0 0, you will get 1 0 0 only. A power n is equal to 1 0 0 0. N is equal to lambda I, because you are assuming that is true. That means lambda I means lambda multiplied by 1 0 0 1. Equating the corresponding terms, you will get lambda is equal to 1 and lambda is equal to 0. On one hand, lambda is equal to 1 and the other hand, lambda is equal to 0, which is not true. This is not true. This is not true for any lambda. Not only that, you take any natural number n and power it and you will get this only. That means this is not true for any lambda and n. So there does not exist any lambda and any n also. Therefore, the option 4 is not true. Let's move to the other options. Option 1, a square has distinct eigenvalues. Right. For that, again, we take a counter example. Let a be 1 0 0 minus 1. And what are the eigenvalues of this one? The eigenvalues are plus or minus 1, because it's a diagonal matrix. So for a diagonal matrix, what are the eigenvalues? The eigenvalues are the diagonal entries. So they have the distinct eigenvalues plus or minus 1. But whereas if you to square it, then it will be identity matrix, and the identity matrix has equal eigenvalues, same as 1. So a square has eigenvalues 1 repeated twice. So that means your option says a square has distinct eigenvalues. No, a square can have equal eigenvalues also. There is a counter example. So that means in general, option 1 is not true. We move on to option 3. Determinant of a square is equal to lambda 1 multiplied by lambda 2. For this is again we take the same counter example. Let A is equal to 1, 0, 0, minus 1. And we have seen in the above, lambda 1 is 1, lambda 2 is minus 1. And A square is the identity 1, 0, 0, 1. Agreed. Now, let us take the option 3 is true. Option 3 is true. Then in that case, then now lambda 1, lambda 2, that is 1 into minus 1 is equal to lambda 1, lambda 2 is equal to determinant of A square is equal to determinant of A square is determinant of the identity. The determinant of identity is 1. So if you assume option 3 is true, then you will get a contradiction. What is the contradiction? Minus 1 is equal to 1, a contradiction. So your assumption that the option 3 is true is not true. Therefore, option 3 is not true. Summarizing all these things which we have already seen, option 2 is the answer for us. So the answer to this question is option 2. Yeah, that is the detailed discussion of the solution of 5 questions that are from the linear algebra that have appeared in the TS Set 2019 examination. And I am sure that you have understood the solutions of all these 5 questions. And if you like my videos, please like, share and subscribe. I wish you all the best. Thank you.